Bismillahirrahmanirrahim. The objectives of this chapter are: define two collinear vectors in space, define three coplanar vectors in space, define reference and base in space. Collinear vectors. Definition. Two vectors in space, u and v, are said to be collinear if and only if they can be represented on the same straight line and one of them can be written in terms of the other. U equal to kv, with k belongs to R. Example given the adjacent figure: are the two vectors u and v collinear? In this figure we have vector u and vector v. So these two vectors have same direction, they are parallel to each other, but they have opposite sense. So we can say that these two vectors are collinear. If we locate a point O in the space and we draw a vector OA equal to vector U and a vector OB equal to vector V, so the 3 points OA and B are on the same line, they are collinear. Therefore, vector U and vector V are collinear. Can determine a relation between these two vectors such that u equal to minus 2v. Remark: to prove that 3 points in the space OA and B are collinear, we form any two vectors of these 3 points, and we have to find a relation or to determine a real number k between the multiplied by the second vector to get a relation between these two vectors. So OA equal to K OB. To prove that 3 points OA and B are collinear, we form two vectors of these 3 points, and we have to find a relation between these two vectors such that OA vector equal to KOB vector. Coplanar vectors. Definition. 3 vectors in space u, v, and w are said to be coplanar if and only if they can be represented in the same plane and one of them can be written in terms of the others. Otherwise, we can write w vector equal to alpha u vector plus beta v vector, with alpha beta are two real numbers. In this example, we given for 3 vectors u and v and w. Are these 3 vectors coplanar? So we locate a point O and we draw a vector OA equal to u, a vector OB equal to v, and a vector OC equal to w. These 3 vectors are in the same plane, so the 3 vectors u, v, and w are coplanar. Remark: to prove that 4 points OA, B, and C are coplanar, we form any 3 vectors of them. We find a relation between the 3 vectors. OC vector equal to alpha OA vector plus beta OB vector, and alpha beta belongs to R. Base and system in space. So given the 3 non-coplanar vectors I, j, and k in the space, OIJK is called a reference system. The triplet IJK is called a base in the space. A system OIJK is called orthonormal system if the 3 vectors I, j, and k have the same norm, or we can say magnitude or length. So norm of I equal norm of j equal to norm of k equal to 1 unit of length, and the 3 vectors are orthogonal 2 by 2. That means I vector is orthogonal to j vector is orthogonal to k vector. We have the point M of abscissa x, ordinate y, and elevation z. Vector OM can be written as xi plus yj plus zk. So x is called the abscissa of M, y is called the ordinate of M, and z is called the elevation of. Using Geogebra software, the space is referred to an orthonormal system OI, OJ, and OK. So the red axis is the abscissa axis, the green axis is the ordinate axis, and the blue axis is the elevation axis. Let's see A on abscissa axis. It moves on this abscissa, so it has as ordinate and elevation 0. Look to point B. Point B moves on ordinate axis, so it has as abscissa and elevation 0. Look to point C. On elevation axis, it has as abscissa and ordinate 0. And if we locate to point D, which is in the plane X or Y, so this point moves on this plane. In this example, we have to locate the following points. Look to A. The coordinates of A are 1, 0, 0. A belongs to x-axis. B, 0, 2, 0. So B belongs to y-axis or ordinate axis. C is B. So C on Z or elevation axis. Point D has 1, 2, 0. So this point is in the plane X or Y, and the points E 1, 2, 3. Pay attention. To locate points E, we have to put a point on abscissa axis 1, since the abscissa of E is 1, a point on ordinate axis 2, since the ordinate of E is 2, and we draw the orthogonal projection of this point at this point. These two orthogonal projections intersect at D. Then we make the elevation that is parallel to elevation axis OZ, and from 3 on Z axis we draw a line parallel to OD. So this elevation and this one intersect at a point. This point is E. Properties. Given the two vectors u and v of the following components, we have w vector equal to au vector, with a is a real number different than 0. So the components of vector w are ax, ay, and az. If you multiply any vector u by a real number a, we get a new vector w has as component the same components of the u vector multiplied by the real number a. If w vector equal to the sum or the difference of the two vectors u and v, then the components of w vector are the sum or the difference of the components of the two vectors u and v. If we have two vectors u and v, collinear vectors, that means u vector equal to k v vector, with k belongs to R. And this relation exists between the components of u vector and v vector, x over x prime equal to y over y prime equal to z over z prime equal to k, with x prime, y prime, and z prime are different than 0. Try to do the following example. Take your time. Check your answer. Properties. Given the 3 points A, B, and C in the space, we have the components of vector A, B are xb minus xa, yb minus ya, and zb minus za. The coordinates of the midpoint M of segment AB are the following, and the coordinates of the centroid G of triangle ABC are the following. Remember that the centroid of a triangle ABC is the intersection point of the three medians in this triangle, and median means the segment that joins the vertex of this triangle to the midpoint of the opposite side. Try to do the following example. Take your time. Check your solution. Also the following example. Yes. Coplanar vectors in a reference system. Property. Three vectors u, v, and w are said to be coplanar if and only if there exist two real numbers alpha and beta such that w vector equal to alpha u vector plus beta v vector. And therefore, we have the following system of three equations. Following example 5, we have 4 points. We have to verify whether the 4 points are coplanar. Okay? Just here to do the following exercise, we have to determine 3 vectors from the 4 points. Any 3 vectors. For example, AB vector, AC vector, and AD vector. Then we have to write 3 equations in terms of alpha and beta. We determine alpha and beta from the first 2 equations or the second 2 equations or any 2 equations. Then we verify these 2 values in the third equation. If alpha beta verify the third equation, so the 4 points are coplanar. If not, so the 4 points are not coplanar. Take your time. Check your answer.